Hello everyone, I'm Mallikarjuna from Cambridge Institute of Technology, Bangalore. I'm currently pursuing my engineering from electronic and communication background. Today I and Mark Anthony have completed this internship on IoT of Things from MSD. Let's see the contents which are covered during this internship. The topic learns Introduction to IoT, Applications of IoT, Advantages and Disadvantages, and about the embedded systems. And the last thing is the project on IoT and the conclusion. In this internship, we learned about C programming language, data structures, conditional statements, operators and arrays, functions, pointers and strings, storage classes, and preprocessing. Data types in C are mainly categorized into T types, primary data types, derived data types, and user-defined data types. C supports the conditional statements like if else, and switch statements. And we have learned about looping statements, while loop, do while, and for loops. While loop is used to repeat a set of instructions when we doesn't know the number of times the statements to be repeated. Whereas a for loop is used when the number of iterations are known. Operators are the symbols that are used to perform arithmetic and logic computations on operands. Operands can be integer, floating point, or character variables. Various types of operators supported by C are arithmetic, assignment, bitwise, conditional, increment and decrement, logical, rational, and special. Array is a linear data structure that is used to store the elements. We learned about single dimension array and multi-dimension arrays. We have learned about some built-in functions, user-defined functions in this internship. User-defined functions are the functions which are defined by the programmer. Pointer is a derived data type that stores memory address as its value. It is used to point the location where the variable is stored. And the strings are a sequence of characters. And we learned about the storage classes like static, auto, Eastern, and registers. And we even learned about the C++. C++ is an object-oriented language where we learned about class and object creation. A class is used to specify the format of an object. An object is a real-world entity, an entity which has data and functionality. Class is a user-defined data structure which binds the data and functions together. And we learned about constructor and deconstructor. A constructor is the member function with the same name as that of class, and deconstructor is used to deallocate the memory when an object is destroyed. Our project is on IoT, Internet of Things. The definition. The Internet of Things describes the network of physical object things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. In short, the Internet of Things refers to a rapid growing network of connected objects that are able to connect and exchange data in real time using embedded sensors. In simple words, it refers to the process of connecting everyday physical objects to the Internet. Like cars, lights, refrigerators, and more appliances can be connected to the IoT. Applications of IoT. All the electric vehicles are mostly constituted of IoT devices, and some of the high-end cars and bikes uses Bluetooth sensors and GPRS tracking devices. Smart home. IoT devices used in home automation are wireless security cameras, smart voice assistants, automatic switching lights, etc. All the devices are interconnected using internet collectively to make a smart house. We use Internet of Things in our everyday life. Smart pollution control. Multiple stations are set up in different locations of city to monitor and collect data, which is then processed and then used to apply solution based on the issues to reduce the pollution. We use different kind of sensors to sense the atmosphere, the humidity, and the moistureness present in the environment. And we collect this data and give it to the processor, which will process us and gives the precautions to be taken. Smart healthcare. There are various systems used in healthcare sector such as glucose monitoring system, health rate monitoring system, remote patient monitoring systems. Smart cities. Smart cities use IoT devices such as connected sensors, lights, and meters to collect and analyze data. The cities then use this data to improve infrastructure, public utilities, and services, and more. There are many more applications of IoT devices in many other sectors which are under development. Efficient resource utilization. If we know the functionality and the way that how each device work, we definitely increase the efficient resource utilization as well as monitor natural resources. Minimize human effort. As the devices of IoT interact and communicate with each other and do lot of tasks for us, then they minimize human efforts. Save time. As it reduces the human effort, then it definitely saves out time. Time is the primary factor which can save through IoT platform. Improve security. Now if we have a system that all these things are interconnected, then we can make sure systems more secure and efficient. Internet of Things saves most of the time as we use the technology to control the all the physical activities. Some of the disadvantages of IoT are security and complexity. Security. IoT systems are interconnected and communicate over networks. The system offers little control despite any security measures, and it can be led the various kinds of network attacks. Complexity. Designing, developing, and maintaining and enabling the large technology to IoT system is quite complicated, and there are many new extensions of IoT devices which are still under development. And we learnt about the embedded systems. Embedded system is nothing but the combination of hardware and firmware which is intended to do a specific task. The different categories of embedded systems like standalone, real-time, network, and mobile embedded systems. The embedded system has different components like system core, memory, output ports, other devices, and input ports. System core, which acts as the brain of the embedded system. The input ports, which are used to connect the peripherals for the communication with the external world. Memory holds the control algorithm and other configuration details. The different components used as the core of an embedded system are general purpose and domain specific processors, microprocessors, microcontroller, digital signaling processors, application specific integrated processors, and many others. The different types of memories which are used for the storage purpose in the embedded systems are ROM for storing the code memory like MROM, PREROM, EPROM, EEPROM, Flash, and EVROM. And the different types of RAM are SRAM and DRAM. There are different types of communication interferences. There are onboard communication interference and external board communication interface. Onboard communication interface refers to the different communication buses which are interconnected with the various integrated circuits and the other peripherals within the embedded system. The external communication interference are the to communicate with the outside world. These are like RS-332, USB, Bluetooth, Wi-Fi. As we discussed about the components of the embedded system, the core, I/O ports, memory, other devices. Core consists of CPU and ALU. It acts as the brain of the system. I/O ports. These are the ports used to send and receive information to communicate between input and output devices. Memory. It consists of both primary and secondary memory. All the programs or the instructions are stored in memory. Other devices. Other devices are used to support the performance of the system, such as cooling fans to reduce the heat, sensors, and actuators. Project title and requirements. Title of our project: IoT based home automation solutions. By implementing this system, it is possible to explore a variety of different engineering challenges, including software programming, PCB design, Wi-Fi, and TCP or IP protocols, web server, logic design, and other aspects. This automation system provides great insights to the challenge of software and hardware design. Project requirements. Since our project is purely simulation, we use simulation tools like PixSimLab, Arduino IDE, Arduino Uno board, and mobile Blynk app to simulate this project. We use this Arduino IDE to develop our source code in it. The operating voltage of this Arduino board is 5 volts. It has 14 I/O ports, in which 6 are analog input pins. It has a flash memory of 32 KB and 2 KB of SRAM, 1 KB of EEPROM, and 16 MHz clock speed. Each of the 14 digital pins on the UNO can be used as input or output using pin mode, digital write, and digital read functions. They operate at 5 volts. Each pin can provide or receive maximum of 40 milliamps and has an internal pull resistor. Pin number 0 and 1 is used to receive and transmit the serial data. Pin number 2 and 3 for external interrupts, and pin number 5, 6, 9, 10, and 11 provide 8-bit PWM output with analog write function. Pin number 13 is a built-in LED connected to the digital pin 13. When the pin is high value, the LED is on. The pin is low, it's off. The Arduino UNO communicates with the computer with the help of UART serial communication, which is available on the digital pins 0 and 1. 0 is used for transmitting and 1 is used for 0 is used for receiving and 1 is used for transmitting. Conclusion: Arduino IoT Cloud is an application that helps makers build connected objects in a quick, easy, and secure way. You can connect multiple devices to each other and allow them to exchange real-time data. You can also monitor them from anywhere using a simple user interface. The applications of IoT are easily programmable using Arduino and can be accessed using applications such as Blynk IoT. In this project, we built a smart home which will turn on the light as the day becomes darker, the automatic AC and heater. As the temperature goes high, the AC will get on, and as the temperature goes low, the heater will turn on automatically. And we used serial tank to check the water levels in the tank. If the water levels goes below the specified level, the input valve will be open, and when the water levels reach the maximum, the input valve will be closed. Now my friend Mark will explain the simulation part. Thank you.
Now let's get started with the simulation. These are PixSim Lab simulator. We are going to tools and select remote tank, and we are connecting it to the pins. Now it's connected. Now we are going to modules and opening up the spare parts. Here's the LED and switches. We'll turn it on and off in this button, and there are pins, analog and digital pins. Now we have our tank having inflow. The inflow is started and the water level is rising. It will increase up to 2000 and it will turn it off after that. Now we are stopping it, and now outlet is turned on, and then now we'll stop it. Now we'll see how the heater works. As we can see, when the temperature is varied, the heater will be turned on. If the temperature will rise above 36 degree, Now once if it is about 36 degree, the heater will turn off. Now let us see about the cooler. When the cooler is turned on, the temperature is decreasing, as we can see. Now let us see with the light sensor. Now when there is daylight, the LED will not be turned on. The LED is off as we see, and now as we increase the resistance, when the light goes down, the intensity of the LED is increased. This is the total project. Thank you to Emertxe team. Thank you.